Hello. Okay, while we wait for the others, do you want to give these two questions a try so long? Tinashe, if you're feeling confused by anything, just let me know and ask questions. It's just the two of us here at the moment, so you can ask whatever you need. Oh, let's see. Okay, so GH is equal to 12. That's looking good. Double check, but I'm sounding good. So we got 15 squared minus 9 squared. 12. Beautiful. Nice job. Okay, I know that question one's a bit trickier, but I want you to give it a try. Hi, Tiamo. There's two questions to try so long. Give them your best chance. Ask questions if you need. I know question one is a little bit trickier than question two. So if you're struggling, you might want to start with question two. But question one's quite a nice, juicy one that I want you to give a try. We're going to do a bunch of juicy questions today. Those of you who have just joined, there are two questions on the board waiting for you to give a try. Question two is a little bit easier than question one. Let me actually just write there. This one's a bit easier. It's just recapping what we did on Monday. So just some more Pythagoras questions. Question one's a little bit of problem solving. I'll see how it goes. Beautiful. Nice answer for question 2. Now give one a try. I know you can do it. We're going to give everyone a chance to get on and give these a try. And then we'll start making our way through today's lesson. Hello to those of you who have just joined. 2 questions for you to try. Got a couple who have felt brave and given us answers for question 2. And the one that I really want you to try is question 1. So I'm just trying to figure out where I think what happened. I think what you did, so with that answer, you're on a really good track. But I think what you did, and I could be wrong, is when you squared the 2x, I don't think you squared the 2. So I think you made that 2x squared instead of 4x squared. Let's see if that helps. I think that's where your 41.6 is coming from. Hello to everyone else. Give these questions a try, and then we'll go through them together. We haven't got the correct answer for question 1 yet, so that's still up for grabs for anyone who's feeling brave and wants to give it a try. I'm sure your brain's all tired. First week back at school. It's always tough. Don't be sad. I really think it was just a squaring situation. Okay, I'm going to give you guys a couple more minutes to work through these 2 questions, and then we will talk about them together. But they are both good ones to know how to do, because we're going to do some tricky Pythag questions today. But they're going to help us in our next section that we're going into after this. Nice job, Kamba. That's definitely right for question 2. I'm going to give you guys a helping hand for question 1, because I think some of you are close. Nice. That's okay. Thanks for letting me know. Okay, I'm going to start going through these questions. So I'm just going to turn off my video for a second. See you just now. Okay, So lots of people started with question 2. So let's start with question 2 when we go through this. So first of all, we know that this is a right angle triangle. We know that this is our hypotenuse. Let's just write that in so we can get used to how to spell that. And the hypotenuse is always the longest side of a right angle triangle, and it's the side that is opposite to the right angle. Okay, and we learned Pythag on Monday, so we can say 15 squared is equal to 9 squared plus GH squared, and we have to give our reason, Pythagoras. Okay, and then we move that 9 squared over and we get GH squared, and we figure out what that is in our calculator, and then we square root it. So we get 15 squared minus 9 squared, and we square root it, so we'll get 144 is equal to GH squared, which means that GH is equal to 12. Oh, big 2. There we go. Okay, so those of you who got that, well done. That was really, really good. Now 125. Oh, okay. I see what you say. I'm not going to say that that's right or wrong just yet. We'll get through to that now. Let's see. So for question one was a little bit trickier. And I'm going to give you a very, very similar one to this in our next question. So I want everyone to listen and make sure you understand. And if you don't understand, then just ask for more help here. So here our hypotenuse is 125. So we're going to say 125 squared is equal to x squared plus 2x squared. And our reason here is Pythagoras. And we have to put that whole thing in brackets, otherwise we're not going to land up squaring our 2. So we have 125 squared is equal to x squared plus 2 squared, which is 4x squared. All right, so that's our first step. Now, if I square 125, we should all have our calculators nearby. I get 15625, and that is equal to 1x squared plus 4x squared, which is 5x squared, because they are like terms. And so because they are like terms, we are allowed to add them. Okay. Now I want to get x squared isolated, so I'm going to divide both sides by 5, so that 5 will go away. So we're going to divide that big number by 5. I get 3125 is equal to x squared. And so if I want x squared to be alone, I'm going to square root that number. And I get 55,90. And that's going to be equal to x. Okay. Now, is there anything about this question that anyone would like me to go over again, or would like explained again, or something that they're not understanding? Because you're going to get a question very similar to this next, and I want you all to be able to do it. All okay? Does anyone need to sit here any longer?
Yes, ma'am.
No problem. Okay, about question 1. So let's just, that's okay. I'm happy to go through this question again. I'd always rather ask for help than feel confused. So I'm just going to go through this one more time. So anyone else who's feeling confused, you can listen here, and hopefully it will make more sense to you as well if you're feeling a bit lost. Remember that this is a tricky question. Because Pythagoras is quite an easy concept, they like to give tough questions. It's how they sort of make the questions a bit harder. Okay, now whenever we set up Pythagoras, we always say this side squared. So our hypotenuse squared is equal to our one side squared plus our other side squared. And our reason for this is Pythagoras. Okay. So if I put into my calculator 125 squared, I'm going to get the answer 15625. That's what that means. Okay. If I'm saying 2x squared, that's the same as me writing 2x times 2x. And this is the same as me writing x times x. Okay, you don't have to write this step up. I'm just showing for those of you who are feeling a bit lost. So 15625 is then equal to 2 times 2, which is 4, and x times x, which is x squared. And x times x is x squared. Now, because these are the same, they're both x squareds, that makes them like terms. So the same way I can say x plus x is 2x, I'm allowed to add those two because they are like terms. So 15625 is equal to 4 plus 1, which gives me 5x squared. Now we're trying to get x to be alone. So our next step here is we want to divide both sides by 5 so that x squared can be alone over there. So I'm going to say that big number divided by 5, and that gives me 3125 is equal to x squared. Okay, and then when I need x to be alone and it's being squared, I'm going to square root it. And so I get the answer of x is equal to 55,90. And that would be our answer. Okay. So yeah, confused with number 2. All right, we can go through number 2 again. So for number 2, we've just got our right angle triangle. This is the side we don't know. We don't know GH. So we always have our hypotenuse squared, and then it's going to be equal to the one side squared plus our other side squared that we don't know. And that's our reason is Pythagoras. Okay. Now I'm trying to get GH to be alone. So I want to move that 9 squared onto the other side. So 15 squared minus 9 squared is going to be equal to GH squared. Now I'm just going to put that straight into my calculator. 15 squared minus 9 squared gives me 144, and that is equal to GH squared. And now because we don't want it to be squared anymore, we want to square root that so that that square goes away. And the square root of 144 is 12. Okay, so that's looking at a slightly easier question and then a slightly tougher question with Pythagoras. Okay, I'm going to give you a similar one to question 1 that I want you all to try now. It's very, very, very similar. Okay, so try and follow the same sort of ideas that we did just now. And if you need help, just let me know or write some comments or unmute yourself. I'm happy to help. Okay, I'm not going to help you with the whole thing. I'm just going to help you with the first line so that those of you who are feeling a little bit lost don't feel too lost. Our hypotenuse is that one. So we're going to say 3x squared is equal to our one side squared plus our other side squared. If you want to keep it in brackets, if that makes it feel better, that's fine. And our reason for that is Pythagoras. Okay, that's just to help you with the first line. Let's see if anyone can take it from there. Oh, okay, Kamba's coming with an answer. So Kamba, I get a very, very close answer, but it's not quite the same. I'm also not getting 5,05. I mean, you're in good company because there's two of you. Nope. I also didn't get 8. Look, my answer might be wrong. So there's always hope that one of these is correct. We'll go through it together. But I do think mine is right. We just got our first correct answer. Oh, it's so close. It's so close. It's so, so, so close. There's just something wrong. Nope. Okay. Let's take you out your misery. 3x squared is going to give us 9x squared, which is equal to x squared, plus 16 squared, which is 256. Okay, so if you got to that point, then give yourselves a nice big tick. Now I'm going to move that x squared over. So 9x squared minus x squared is equal to 256. 9 minus 1 is 8. So 8x squared is equal to 256. I'm going to divide both sides by 8. And so x squared is equal to 32. And then I'm going to square root both sides. And I end up getting x is equal to 5,66. So our closest was 5,65. But the reason it's not 5,65 is because our full answer here, let me write all the decimals, are 5,6568. And so this 6 makes that 5 go up to 66. That's why I was saying you so, so, so close, just not quite there. So try and see. Oh, okay. Well, can you try and follow which lines you have similar to me and then where yours starts going a little bit different?
Ma'am, I started with the first line was very much correct.
Okay, good.
And then the second line, I didn't say 9x times 2. I continued by saying 3x squared equals to 1x squared plus 256 squared.
Okay.
And then I then said 9x squared is equal to 257x squared, then power to
Ah,
then
okay,
I'm
okay.
wrong.
Okay, so that's I'm so glad you said what you were doing. So you were doing really good things. That 1x squared and that 9x squared were really, really good. But what happened here is we can't say that this is 257. We're not allowed to add that one because this and this are not like terms. There isn't an x squared over there. And so because it isn't an x squared, we're not allowed to add those together. So that 1x squared and the 256, they're not the same as each other. And that's why we have to keep them separate. So like that's that guy, and the other one's a light blue.
Okay, thank you, ma'am.
No problem. You see, other people made the same mistake as you. That's why it's so good to make mistakes and then to talk about them, because then we can figure out where we're going wrong. Well done. All right. Let's go on to another question. I promise the next question is not as nasty. Okay. So you did something similar to this in our lesson on Monday, but there's something a little bit different about this question. So let's have a look at it. The length of the diagonal of the square below is 25 centimeters. Determine the length of the side of the square. Okay. So my question to you is, we know that the diagonal is 25. Okay. If it's a square, what does that mean about this side and that side?
Right angle.
Good. Okay, good. They are a right angle. What else can you tell me about those two sides? If it's a square.
I think it's all sides are equal.
Beautiful. Well done. So because it's a square, that's 90 degrees, and this side is equal to that side. Okay. So, we've created a right angle triangle, which is what we need for Pythagoras, which is good. And we know that those two sides are the same. Now, because we don't have a length for that side, we can just call that side x. And because we know the other side is exactly the same as it, we can also call that side x. Okay, so this one's a little bit easier because we're not dealing with more numbers, but I want you to give this one a try for me, please. Okay, so let's see how this one, I'm not going to do the whole thing again. I'm just going to help you a little bit. Okay, so we've got a 12 and a half. Okay, so you're actually you're not on a bad track at all, Kumba. I think you haven't square rooted it yet. Let me keep the same format that I've been doing. And I think you may not have squared the other side. Okay, so let's see if anyone got to that point over there. And then we can use our calculator a little bit. 25 squared is going to give us 625. And now these are both x squareds, which means they are like terms, which means I'm allowed to add them. So I've got 1x squared plus 1x squared, which gives me 2x squared. Okay. It's gonna let you try from here. I'm seeing a very, 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 very close answer in the comments. There we go. Nice. So step from here, we're going to divide both sides by 2. So that 2 goes away. And 625 divided by 2 gives us 312,5, and that is equal to x squared. And so if I'm wanting x to be alone, I'm going to need to square root both sides. So the square root of 312,5 gives me, so x is going to be 17,67766. And so because I always round off to 2 decimal places, this 7 is going to affect that 7. And so x is going to be 17,68. And we're dealing with centimeters. So we're going to put centimeters in. Okay. So it's very similar concept to what we've been doing. This would be problem solving. So it wouldn't be considered like your general type of questions, but they do like to ask these types of questions with Pythagoras. It's one of the ways that they can make it a bit tougher. Does anyone need to sit on this question before we move down? Okay, cool. Okay. Nice, easy question. Oh, yay, well done. Sorry, I seem to have put the wrong question here because I'm obviously losing my mind. This is not the question for this shape because this is not a trapezium. I'm sure that I have put the wrong picture somewhere. Okay, so let's just ignore that for the moment. I would like something which we haven't spoken about yet, but it's something we're going to be talking about in one of our next courses. I would like the perimeter of triangle ABC. Can someone tell me what a perimeter is of a shape?
Is it the total length of the sides?
Good. It's the total length. So it's the total length of the sort of outside of the shape. Well done. So in this situation, if I was wanting the perimeter of triangle ABC, I'm wanting that line plus that line plus that line. Okay. Now I'm telling you, it should have been written in this picture already. I'm telling you that angle B is at 90 degrees. So I want you to think about how you can find your missing side. And then I want you to think about what your perimeter would be when you add them together. So think about how to find that side and then think about how to add it together. And let's see if we start getting some right answers coming in. I can tell you that it's a nice answer. So if you're getting decimals, then something may have gone a bit wrong. Oh, sorry. Did my sound go funny? So all I'm wanting you to do for this question is find the perimeter of this triangle. So think about how you're going to find the missing side, which is AC, if it's a right angle triangle. And then I want you to add those sides up together to give me my perimeter. And if your answer is a decimal, then you may want to retry your answer. Okay, Canva has come in strong with an answer. I'm not going to confirm or deny it just yet. Let's see. Let's see what other people figure out. Okay. And we're getting very, very similar answers coming in, which is great. So let's go through this one. So AC, let's get back into blue. AC is our hypotenuse. So AC squared is equal to 5 squared plus 12 squared. And then our reason for that is Pythagoras. That's okay, Avile. Thanks for letting me know. So AC squared is going to be equal to 5 squared plus 12 squared, which is 169, which means when we square root it, we're going to get 13. So now we know that that's 13. So our perimeter is going to be 13 plus 12 plus 5, which gives us 30 millimeters. Who got that right? Let's see. Yay, well done. We've got quite a few in the chat who've got it. Nice. Nice job. Well done. Tansy, Canva, Tiamo. Good job, guys. Nice. Okay, good. If you're feeling good with this one, I'm going to give you a slightly harder one. And then I've got a little, well, you know what I'm going to do? I'm going to give you a nice question. I'm going to give you a question before we get into the next one. This is just for bragging rights. Let's see who can solve this riddle first. I want to know what number that red triangle is equal to. Let's see who can figure this out. So the circles are equal to something, the squares are equal to something, and the triangle is equal to something. And I want to know what that triangle is equal to. First person to get it right gets bragging rights for the rest of this lesson. Get out your piece of paper, see what you can figure out. You may want to remember things like BODMAS. That might help you. Maybe I'm being too nice. I'm probably being too nice. And if no one has any idea where to start, let me know. If you feel completely lost, just shout.
Ma'am, is the triangle 2?
No, the triangle is not 2. You were so close. Sinclair, the triangle absolutely is a 1. You get bragging rights forever. Well done. Nice job. Okay, let's try and talk through this. I'll try and give you more like this and I'll I'll try and give you were so close, more like this in our future lessons. So try and see how we go about this. So we know that 2 of the same shape equal 10, which means that that circle must be 5 and that circle must be 5 because they must be the same as each other. So we know that's 5 and 5. And so we know that this is 5. And then we know that 5 times something plus something has to give us 12. So if we played around and we said 5 times 2, that would give us 10. And 10 plus 2 gives us 12 because the squares have to be the same. And so now we know that the circle is 5 and we know that the square is 2. We know that that circle is 5 and that circle is 5. So this is saying, 10 minus something times 5 needs to equal 5. And so we know that this answer here needs to be 5 because our answer needs to be 5. And the only thing times 5 that would be 5 is 1. And so our triangle is equal to 1. Well done. You worked it out so quickly as well. Very, 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 very well done. Did anyone else get close? Did anyone who managed to figure out what the circles were? Okay, good. Okay, so quite a few people got to the circles. That's good. Nice job, Sia. The circle is the first part. Okay, did anyone manage to get the circle and the square? Kinsani, well done. Okay, so quite a few people got the circle and the square.
Ma'am, I thought the circle was 3,5, even though I got my answer correct.
3,5. How,
Yes,
how did you get 3,5?
I don't know how I did it, but I see 3,5 and something, then I got 12.
Okay. Okay, lots of you landed up getting the circle and the square, and that's really great. Well, I was trying to help you with the BODMAS because I was worried that you were going to just do the pluses before the times. That's why I put the brackets there. But next time I won't help you. I'll just stay silent. But you guys are going to have to work very fast if you're wanting to beat Sinclair because that was very, very, very quick. But I'll give you another one on Monday. I'll slowly make them a little bit harder through our lessons. All right. Let's go. Let's get back into Pythagoras mode. I just needed to give you something fun before I gave you, not playing. I just wanted to give you something fun before I gave you something mean. So let's have a look at this question. So we are needing the perimeter of this shape. Now, in order for us to have the perimeter of the shape, we need this line, we need this line, we need this line, and we need that line and that line. Okay. Now, we need to be careful with how we go about this because we don't want to do too much work. I want you to remember that this is a rectangle. Okay. And so because it's a rectangle, I should have kept those. That was silly of me to erase them. Let's draw them back in. Okay. Because it's a rectangle, this side here is going to be equal to this side here. And this side is going to be equal to that side. So think about the things we did when we did the properties of quadrilaterals. Okay. So I've tried to give you some helping steps here. If you find the lengths of these sides, some of them are much easier to find than others, then finding the perimeter of the shape shouldn't be too hard. Okay. So if you find, you might want to start with finding RQ. That might be a nice, easy one to start with. Or SP might also be an easy one to start with. And then AQ and then SR. But you can go in any order you would like. Okay, let's see how these go and see if we can get our perimeter of the shape. And there are long ways to do it and there are quick ways to do it. And I don't mind which ways you would like to get it done. But let's see if anyone can get our final answer. It should be a nice whole number, not a decimal, if that helps you at all. So for SR, I don't get a decimal. I'll double check mine. Yeah, I don't get a decimal for SR. I get a nice whole number. Ah, there we go. That's more similar to what I have for SR. So SR wouldn't be 12, but there would be another length that is 12, if that helps you at all. Ah, there we go. Okay, so we have RQ. I'm liking that for RQ. SP, I'm liking that for SP. We're making good progress here, guys. Do you see why Pythagoras is our friend? All these good things. Do we have a full answer coming in yet? Not. Oh, okay. Close. Okay. So come back. Just remember that that's dotted line is not part of our perimeter. I think you may have left off the studio. Nice. Okay. So I'm going to slowly talk you through some of this. And we'll see how it goes. So the reason I said RQ was our easiest one is because it's a rectangle. It's the same as this. So we actually already know that that's 12 centimeters. We don't have to work anything out for it. So we can just say RQ is equal to 12 centimeters. Okay. Now we have lots of different things to find. So if we wanted to find SP, we're looking at this triangle over here. I'm just going to make some space. So SP squared would be 12 squared plus 9 squared Pythagoras. And so SP squared is going to be 144. Well, let's just do this as a whole number. 12 squared plus 9 squared, which gives us 225. And so SP is then equal to 15 centimeters. Okay, so now we know that this is 15 centimeters. And remember, each thing you find, you would get marks for. So it's good. Okay, now if I wanted to find AQ, that's part of this triangle here. Okay, I can say that SQ, so 20 squared, is equal to 12 squared plus AQ squared because of Pythagoras. And so now I'm going to say 20 squared minus 12 squared. I'm lost in the 15. Okay, hold on, let me move back here. Okay. Okay. Do you see the triangle that we're working in, the red triangle?
Yes, ma'am.
Okay, so if we're in that red triangle, then our hypotenuse would be SP. That's what we don't know. And we're going to square it. And then we're going to add the one side, so 12 squared, plus the other side, which is the 9 squared. And if we add these together in our calculator, we should get 225. And so then when we want SP to be alone, we're going to square root that to 225. And so we get SP is equal to 15. Okay.
Thank you, ma'am.
You're welcome. So we know that that's 15 over there. Okay. So now let's move into this triangle here. So we had said that that hypotenuse is 20 squared. My one side is 12 squared. My other side that I don't know is AQ squared. And we know that that is because of Pythagoras. Okay, so I'm going to move that 12 squared over. That's equal to AQ squared. I'm going to chuck that in my calculator. So 20 squared minus 12 squared gives me 256 is equal to AQ squared. So we're going to square root that. And we get 16. Okay, and because this is a rectangle, if this is 16, then this is 16. So we actually don't need to do any more Pythagoras. So then our perimeter is going to be, I'm going to use a wildly different color so you can see what I'm adding. 16 plus 12 plus 16 plus 9 plus 15. And all of that together gives us the beautiful 68. Centimeters. Okay. So just lots and lots and lots of steps. We just have to take one step at a time. Whew, big question, I know. Does anyone need to sit here any longer? Does anyone need to see it? Okay. All right, I'm going to go. We have time for one last question tonight, and then we're probably going to have to call it an evening. Okay. So I've also tried to make this one a little bit easier for you. So find the length of HM. HM is here. And then find the perimeter of the shape. So let's see if everyone can get this right. And remember, we haven't done perimeter yet. So I'm just stretching you a little bit. So don't panic if you're feeling a little bit stressed with perimeter. We're just going to see how we can use Pythagoras in questions. I can tell you you're going to get a decimal answer. So if you have a decimal, then you're right. HM is a decimal. Oh, you know what you've done with HM is 5. You've put your hypotenuse on the wrong side. So you've said 3 squared plus 4 squared equals HM squared. Canva, that answer is beautiful. I'm going to give you 1 more minute to give this a try. And then we're going to chat through this question. Yeah.
Then is M and L 10 meters, or is it H to L that's 10 meters?
No, M to L is 10.
Thank you, ma'am.
You're welcome. Oh, shame, Lorato. And last few minutes of the lessons. Ooh, we have a perimeter answer. Okay. All right, I'm going to start with this little green triangle that I have colored in over there so that I can find HM. My hypotenuse squared is equal to my one side squared plus my other side squared, Pythagoras. I'm going to move that 3 over, and that's equal to HM squared. And we're going to just chuck that into our calculator. 4 squared minus 3 squared equals 7, which means that HM is equal to the square root of 7, which is 2,65 meters. Okay, so this little green dude over there is 2,65. So if I'm wanting my perimeter, let's use a pink. I want 4. So my perimeter is going to be 4 plus 6 plus 5 plus 10 plus what we've just figured out, 2,65. We're going to add this all together, 4 plus 6 plus 5 plus 10 plus 2,65. And we get the answer of 27,65 meters. Well done to those of you who got that. That was awesome. Nice job. And that is where we're going to call it a night. You did really, really well today. Nice work.
Hello, grade 9s. How's everyone feeling? Just with this lesson, are you guys feeling good? Are you feeling great? Is it better than the previous geometry you've done? Are you feeling confident? Just want to get a sense of the room. How's everyone feeling? Okay, it's great with the fire emoji. Canva understands more. Cloma is saying it's eh. Sia is feeling juicy. What does juicy mean in maths here? That is very colorful. Okay, Lutoko also says it's perfect. Others are saying it's amazing. Okay, no, this what I'm getting in general, of course, there's probably different feelings, but what I'm getting is that you guys are doing great, especially with regard to this particular topic. So what I want you to do while you're feeling good, you can keep putting in your answers on the chat. I'll get back to them just now. But what I want you guys to do, I want you to go to the Watobe app when you're done with this lesson before Monday, actually. Yeah, before Monday, because our next lesson is on Monday, remember. I want you to go to the Watobe app, go to pick a topic, click on Theorem of Pythagoras, and then go to use Pythagoras to find side lengths, okay? Because this is what we were doing today. So just so you consolidate your information, watch the lesson that's there. I'm not sure if there's a quiz actually, but if there's a quiz, do it there and just do whatever it is on that. Oh, Kitty is saying hello. Is that a cat? So just do the lessons that are there so that you consolidate your information. If you have any questions, you can bring them can come slightly early. We usually start like 5 minutes before. Maybe you can ask questions, and if the teacher is feeling nice, maybe you'll get a chance to have your particular questions answered. So yeah, and then let me just get on with this, our leaderboard. So these are our superstars. I saw that Tiamo and Adora are here. I don't think Tandolwetu is with us, but wow, Tiamo, this is amazing. this is great. You did very well. 14 activities is a lot, especially considering that we just came from a break, and so a lot of people weren't using the app. For the new names that are here, so every week we do a leaderboard, and what that means is that we see the number of activities that you did on the Watobe app. For us, the activities that you did symbolize efforts. They symbolize you trying and doing stuff. Doesn't have to be right. Even if you did activities and you got all of them wrong, we still count them, you know? So every time you're doing activities, we can see it on our side. And that's just all we want for you. We want you to watch the videos, do the quizzes, do the exercises, and just put in the effort. So congratulations to Tiamo, Tandoleto, and Adora. And I don't like it when there's 3 people here. I want always to have a lot of names. So hopefully we'll do the next one next week, Wednesday. So hopefully there'll be many more names. And just before I let you go, our next lesson is on the 18th of October. I've already said that on Monday, and we'll be using Pythagoras in isosceles triangles. So triangles with 2 equal sides. So make sure that you prepare however you can with that, but just come to the lesson, even if you haven't done it in school. And then, yeah, let me just go back to seeing your comments. So I see if anyone has any questions or comments. Loretta is asking where they can watch the video today. Okay, so for those of you who don't know, all these videos are being recorded, right? So you can go to, let me just type it here on the chat, watobe.co.za. So you go to watobe.co.za, and then on there, you're gonna go to live lessons. There should be a button that says live lessons, and then under there, you go to grade 9, and you can watch not just this one, but every other lesson that you've missed. You can watch it over there, you know. But of course, we recommend that you come live because you can interact and ask questions, and you don't have to have this lesson you need to watch later if you just get it over it now. So yes, thank you very much, Ms. G. So live lessons, grade 9, choose lesson, then watch this. Does anyone have any comments or any questions? Or are we all good? Okay, I don't think anyone else has any questions. We'll see you all on Monday. Enjoy your weekend and enjoy the rest of your week. Bye, everyone.
Bye.
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 Bye. Bye, Canva.